All right, you guys, so I don't know how far you have gotten on your paper, but I'm going to go ahead and give you an example of using the Pythagorean theorem to find the distance between 2 points. This is a very important way we use the Pythagorean theorem. And in fact, the Pythagorean theorem and the formula to find the distance between 2 points is the exact same formula, it's just rearranged. So the first thing I did is I picked two places. So I picked Denver, you can see up here in the top left-hand corner of the screen, and Lafayette, Louisiana, down here in the bottom right-hand corner of the screen. And I found the longitude and latitude of both places. The longitude of Denver is 105 west, 39.74 north, and the longitude of Lafayette is 92.02 west and 30.22 north. So it's important to have that west and north there. If you take a look at this map of the world, and I think I put in the international date line correctly, over here in Greenwich, otherwise known as the prime meridian. And the reason why I wanted to show you the entire map is because if you look at the prime meridian and the equator, it splits the world into 4 quadrants, right? Just like if we're doing just as if we're doing a map of something, right? Or a coordinate system of something. So everything over here, like most of Europe and North Africa here, this is all in the northeast, okay? We are in the northwest, right? Down here we have the southwest, and over here we have the southeast quadrants, okay? So it's really important if you got a city over here, say in Italy, when you're finding the distance, you have to find the distance not only to the prime meridian, but then add on the distance to somewhere else to get the total distance between two things. So you might want to take a look back at what you did and make sure if your cities were not in the same quadrant that you did your distances correctly, okay? So we're both in we're about here. Look, Denver's about there, Lafayette's about there. So what I've been showing you is a close-up of what I'm doing over here, okay? So let's go back to that one. If Denver is 105 west, that means this is 105 going this way all the way to the prime meridian, or in the middle of the ocean. I guess it's not in the middle of the ocean, but 105. And here it's 92 over here. What is the distance between our two longitude lines, right? I want to know what is the distance between our two longitude lines. Like I said, this is 105 and this is 92. So if I just subtract those, so I have 105 minus 92.02. Okay, I get 12.98. Oops, I'm in line mode, you guys. I hope we remember that correctly. Okay, 12.98. And remember, I'm still in degrees. I have not converted that yet. We're 12.98 degrees longitude separated here. And then I want to do, if Denver's all the way up here, almost at 40 degrees north, and Lafayette is down here at 30.22 degrees north, I'll find an exact distance here by doing the subtraction, but it's going to be pretty close to 10, right? I'm almost at 40, I'm at about 30, so we're going to be at about 10 degrees difference here. Let me move this out of the way so I can see the numbers. I'm going to do 39.22 minus 39.74, you guys, sorry. 39.74 minus 30.22, 9.52. So between here, these two vertical lines are both going to be 9.52 degrees difference, okay? So this 12.98 is the same as the distance between here and here, and 12.9 is the same as the distance between here and here. So the next thing I want to do to show you, and I'll do this all before I convert to miles, so I'll just be dealing with these numbers, is the next thing I want to do is draw a line between the two cities. Okay, so Denver, directly between the two cities, and, I didn't give myself enough room. Between Denver and Lafayette, right? Because I don't want to drive like straight over and then down, or straight down and then over, although we might have to depending on the roads. But say I was going to fly a plane, you want to take the most direct route from there to here. If you've ever heard like as the crow flies, that's what we're trying to find, is this hypotenuse here. So if you look at what we've done here, is we've actually created a right triangle. Did you see down here where I just drew that right triangle? And we know how tall it is, right? We found that. The length of the leg tall is 9.25. And we know the length of the base, it's 12.98. And as long as I have a right triangle, and I know the length of one side and I know the length of the other side, I can find the length of the hypotenuse by using the Pythagorean theorem. So here are some notes on the Pythagorean theorem. Okay. Make sure I'm spelling this right. I think it's this way. Theorem. Okay, and I bet you guys already know, because it's so famous, I bet you already know the actual formula, right? The formula is, all right, a squared plus b squared equals c squared. Okay, so if we look at from Denver and we want to go to Lafayette, so I drew this triangle. A and B are the lengths of the legs of the triangle that touch the right angle. So in my case, they were 9.25, and I have not changed to miles yet, and 12.98. It doesn't matter which one's A and which one's B. What does matter is that the longest side, the hypotenuse, is always C, okay? So if A, let's plug these in. If A is 9.25, so I have 9.25 if I'm putting it into the formula, squared, plus MB is 12.98 squared. Now it looks like we're going to have some order of operations because you have to square those before you add them up. Is going to be equal to C squared. So 9.25 squared, 9.25 squared is 85.56 approximately. Plus 12.98. I know 13 squared is 169, so it's going to be close to that. 168.48 approximately. 168.48. Okay, so then I'm going to add those two numbers together. And I get 254.04. Equals C squared. Well, that's not C, right? What's the inverse operation of squared? I have to take the square root of both sides. I'm going to take the square root there and the square root here. So I get C all by itself equals the square root of what I just had. And I get 15.94 approximately degrees approximately. So I'm going to change that equal sign to wiggly equal sign because I did a lot of rounding there. Okay, so next I need to convert that into my 15.94 degrees into miles. So on your paper, we did a very approximate 1 degree is 69 miles. So as you can see, I set up this ratio here. 1 degree is 69 miles. So I'm going to set that equal. I'm going to make a proportion. If I know I have 15.94 degrees, how many miles do I have? So I'm just going to multiply both sides by x, by both denominators, and both sides by 69. Okay, x 69. And on this side, my 69s cancel. And on this side, my x's cancel. So I'm left with 1x, 1 times x, which is just x, right, is equal to 15.94 times 69, which is approximately 1,099.77. 1,099.77 miles apart. Okay, so I will ask you guys if this is correct. You get the same thing if you Google it, and I'll tell you it's not going to be. There's going to be some errors. Some of those errors are going to be rounding, and some of them are going to be because when we use Pythagorean theorem, we use like a two-dimensional map. But it's the same reason why our maps are not as good as our globes, and that's because our globes are round. So we're actually, when a plane flies, they fly up around the globe like this, so the miles are actually going to be longer, okay? So it's not going to be an exact amount. So finish watching this, check your answers, and I'm going to have another video posted that are going to be just more specifically about solving Pythagorean theorem that's not about on the globe.